Good afternoon. This is MCS Geometry Lesson 73, page 483 in your Saxon textbook. Applying trigonometry with two new terms, angles of elevation and depression. Let's begin with the warm-up. In a right triangle, the ratio of the length of the adjacent leg to the length of the hypotenuse is, well, let's look, adjacent and hypotenuse. So we're going to choose cosine. Number 2, find the value of x using a trigonometry ratio. Round to the nearest, and this means hundredths place. Well, here's our angle, and they're defined x, which is adjacent, and we've been given 41, which is opposite. So adjacent and opposite. Here we go. Tangent. So we wrote tangent of 72 degrees equals 41 over x, multiplied both sides by x, and to isolate x, divided both sides by tangent 72. X's come out to 1. 72 comes out to 1. So x equals 41 divided by the tangent of 72. Written this way. You can go ahead and get your answer, and I will go on. Number 3, what is the ratio of a leg to a hypotenuse of a 45-45 90-degree triangle? Aha! Go to your sheet and smart sheet and find the special triangle of 45, and you'll find that the ratio of 45-45 90 is 1 to square root 2. So a leg to a hypotenuse is 1 over square root 2. Well, why can't we leave it like that? Because we need to rationalize the denominator. We cannot leave any weird thing in the denominator, and a parentheses is one thing and radical sign is another one. So we multiply the top and the bottom by square root 2, multiplying by 1, making the bottom square root 2 times square root 2 be 2, and the top square root 2. Let's look over at our answers. We could have square root 2, 2, square root 2 over 2, or 2 over square root 2. Our first answer was 1 over square root 2. After we rationalized it, we find that C resembles our answer. Going on to the lesson, angles of elevation, angles of depression. In this drawing, a person is sighting a bird. This is their eyesight, or their line of sight, parallel to the ground. This is the elevation of the flight of the bird. If the person is looking up, this is the angle of elevation. An elevator takes us up in this case. And if the bird is coming down to sight the person, this angle is being measured downward, so it is the angle of depression. These two terms is what your new lesson is about. Everything else is we will use trig ratios we've already learned to determine height or distance away, or the hypotenuse. At least 2 pieces of information need to be given you for you to be able to do this. In example number 1, we need to find the horizontal distance between the kite and the child. The horizontal distance is the x, listed right here. In this example, our angle 1 is 36 degrees. How far away is our hypotenuse, which is 80 feet. And our x, which is our distance, horizontal distance we're trying to figure out, is adjacent to the angle. Well, what do we have? We have an adjacent and a hypotenuse. An adjacent and a hypotenuse. So we're going to use cosine. And we have that set up on the next page. Cosine of 36 degrees equals our adjacent x over hypotenuse 80 feet. Now, rearranging to solve for x means 80 feet times the cosine of 36. To do this on your calculator, my calculator has me put the degrees first. So 6 cosine times 80 equals 64.721. And of course, we rounded to the nearest hundredth. Or, using parentheses so that it resembles this equation, I wrote 80 times parentheses 36 cosine unparentheses equals, and I got the same answer. So your calculator, you're going to figure out how to use it, but in general, most often you do the degree before the trig function. Your next problem, example 2, is an angle of depression, and it shows an airplane flying at 33,000 feet. And he sees a lake. If the angle of depression from the plane to the lake is 30 degrees, as noted here, depression going down, I can also call it how far from the lake. I can also call it my sight line, whichever direction I am trying to look. And so that's our setup. Now please note that 30 degrees and angle A, are complementary. And angle A and angle B are complementary. Therefore, 30 degrees equals angle B. 30 degrees equals angle B, which reinforces what we already know. The alternate interior angles of a transversal, and this is a transversal, cutting through our parallel lines, our two lines here, are congruent. So, which trig ratio do we use? 33,000 feet is opposite either the B or it's opposite the 30 degrees. And the hypotenuse is what we need. So we're looking for opposite and hypotenuse. We see those right there. So we're going to use the sine. So the sine of 30 degrees equals our opposite, 33,000, over how far, which equals, and if I just divide both sides by 33,000, I will get sine 30 over 33,000. However, rather than writing myself and making how far be in the numerator, your calculator may have a reciprocal button. It may say x over y goes to y over x, or mine said 1 over x. So if I write down the sine of 30 divided by 33,000, hit equals, and then press my 1 over x button, it will give me my 66,000 feet. Now, please note right here that this is the sine of 30 degrees. So this particular problem can be solved as a special triangle, a 1, 2, square root 3 triangle. The ratio of the height over how far equals 1 to 2. Therefore, 33,000 was our height. So 2 times 33,000 will be our how far. A way to get away from having to use our calculator. Example 3, multiple points of measure. I will show you the picture. Here we have the building. Here we have a window washer, noted as point C, and abbreviated as WW. Person A is however far away, but is measuring up to the window washer at 40 degrees elevation. Person B is a little closer to the building and measures all the way up to 70 degrees as his angle of elevation. And it's still, the window washer is located at 60 feet above the ground that they are all sharing. So, window washer is 60 feet. How far away is persons A and B? The height opposite the angle is known. The hypotenuse is known. So, we are going to look for opposite hypotenuse. So, for SOHCAHTOA, so we're going to use the sine. So, we'll plug it in. The sine of 40 degrees equals 60 feet divided by AC. And let's do both of them at the same time. The sine of 70 degrees equals 60 feet divided by BC. So 60 feet divided by the sine of 40 is 93.34 feet for how far away person A is. Person A. And 60 feet divided by sine 70 equals 63.85 feet, which is for person B. Very nice. One more example. One more example shows two buildings. One is 600 feet, one is 800 feet, and we're to determine the angle of elevation from the top of the one to the top of the next. Well, our first job is that this is the opposite side of the 15 degree of this little triangle that we're considering, and that equals the total height, 800, minus the smaller height, 600, so 200 feet. We're trying to figure out how far apart the buildings are, so our horizontal length, and that's our adjacent side. Well, opposite and adjacent are related with our SOHCAHTOA, so our tangent. So we're going to put tangent of our angle, 15 degrees, equals our opposite, 200, over our adjacent, x. Now this gave 746.41, rounded to the nearest hundred, but they asked to the nearest foot. So we're going to cross off our 0.41. So things to remember is angle of elevation or angle of depression is just defining the triangle for you. Remember SOHCAHTOA, sine, opposite hypotenuse, cosine, adjacent hypotenuse, tangent is opposite of or adjacent, to determine which trigonometric function to use. And practice using your calculator to get the same result as the book. Have a great time.